Dear students, in last class we studied Cockraft-Walton voltage multiplier circuit and some equations related to voltage drop, ripple voltage and maximum output voltage. Also we studied optimum number of stages, that is n opt equal to under root Vmax into Fc by I. Today, using n opt and maximum output voltage equation, we will derive an equation for maximum output voltage with n opt. That is, we will substitute the value of n opt in V naught max. So maximum output voltage with n opt stages is equal to 2 into under root Vmax into Fc by I into Vmax minus I by Fc into 2 by 3 Vmax F into C by I whole cube. Taking under root Vmax Fc by I common outside, we get two into Vmax minus I by Fc into 2 by 3 into Vmax into F into C by I. Here we can cancel Fc and Fc, I and I. So we get Vmax into Fc by I into the bracket 2 Vmax minus 2 by 3 Vmax. Subtracting 2 by 3 Vmax from 2 Vmax, we get Vmax into Fc by I into 4 by 3 Vmax. Now let us call this as equation 5. Now based on these, we will solve one numerical. Ten stays Cockraft-Walton circuit has all capacitors of 0.06 microfarad. The maximum secondary voltage of the supply transformer is 100 kV. At a frequency of 150 Hertz. If the load current is 1 milliampere, determine first one, voltage regulation. Second one, the ripple. Third one, the optimum number of stages. For maximum, output voltage. Fourth one, the maximum output voltage with optimum number of stages. First we will write the given data. Number of stages n is equal to 10. Each capacitor is of 0.06 microfarad value. Vmax is 100 kV. Frequency is 150 Hz. Load current I is equal to 1 milliampere. First we have to calculate voltage regulation. Voltage regulation by definition VR equal to no load voltage minus full load voltage divided by no load voltage. No load voltage minus full load voltage is nothing but voltage drop. So I will write voltage regulation as delta V upon VNL. Delta V upon VNL is 2 into number of stages into Vmax, because it is no load output voltage. If we need percentage voltage regulation, then you have to multiply by 100 on RHS. So to calculate voltage regulation, first we need to calculate voltage drop delta V. And that is equal to I by FC into 2 by 3 n cube plus n square by 2. Substituting for I, F, C and N, we get 1 into 10 raised to minus 3 divided by 150 into 0.06 into 10 raised to minus 6 2 by 3 into 10 cube plus 10 square by 2. Simplifying, we get approximately 80 kV. Now we can calculate voltage regulation. On simplifying, we get 4%. Next, we have to calculate ripple voltage, that is delta V, equal to I by Fc into n into bracket n plus 1 divided by 2. I is 1 into 10 raised to minus 3. F is 150. C is 0.06 into 10 raised to minus 6 into 10 into bracket 10 plus 1 divided by 2. Simplifying, we get 6.1 kV. Third one, optimum number of stages. N opt equal to under root Vmax into Fc by I. That is equal to 100 into 150 into 0.06 into 10 raised to minus 6 divided by I. I is 1 milliampere. Simplifying this, we get 30. Remember here, if we do not get a whole number, then we have to round off the obtained fractional number to the next whole number. Next we have to find the maximum output voltage with optimum number of stages. The maximum output voltage with n opt stages is equal to under root Vmax into F into C by I into 4 by 3 Vmax, that is equal to 30 into 4 by 3 into 100 kV, because Vmax into F into C by I under root we have calculated as 30 in the last step. So this becomes 10 into 4 into 100 kV, that is equal to 4000 kV. Dear students, now we will have some important discussion on Cockraft-Walton voltage multiplier circuit. Look at this equation 1, which is for voltage drop. Delta V is equal to I by Fc into the bracket 2 by 3 n cube plus n square by 2 plus n by 6. Here frequency and capacitor both are in denominator. If we increase the frequency value, then the voltage drop can be reduced. Also, if we increase the capacitor value, the voltage drop can be decreased. But it is economical to increase the frequency rather than increasing the capacitor value. So, in order to have lesser voltage drop, we should operate Cockraft-Walton voltage multiplier circuit at higher frequency instead of using higher capacitor values. Similarly, from equation 2, we understand that to have less voltage ripple, we have to operate Cockraft-Walton voltage multiplier circuit at higher frequency rather than using higher capacitor values. Also, we have studied the maximum output voltage with optimum number of stages, that is n opt. In this equation, we are having the maximum output voltage equation as under root Vmax into F into C by I into 4 by 3 Vmax. Since here frequency and capacitor are in numerator, by increasing frequency or capacitor value, we can increase the maximum output voltage, but it is economical to increase the frequency rather than increasing the capacitor value. So increase in the frequency gives us three advantages. One is less voltage drop, lesser ripple, and then increased output voltage. Lastly, we will write application. Cockraft-Walton voltage multiplier circuit. Cockraft voltage multiplier circuit is used for testing the equipments where voltage requirement is from 2 megavolt to 4 megavolt, and current requirement is up to 20 milliampere. Dear students, I will stop the class here and continue in the next class with AC voltage generation. Thank you.